Hello everyone. Today we are going to start the new unit. Unit 2 it's talking about the sound. Lesson 1 is sound waves and hearing. In this lesson we are going to describe the properties of longitudinal waves. Then we are going to classify a sound wave as a type of a longitudinal wave. Then we want to understand that sound requires a medium in which to travel. First of all, please try to put your hand in your throat while you're talking. You will feel like a vibration happens. These are your vocal cords are vibrating. From this vibrating, the air near to your mouth start to vibrate. So we can hear the sound. Okay. To understand more about vibrating and the sound, let's look at the definition of vibration. Vibration is the complete back and forth motion of an object. So all sounds are made by vibrations of molecules through which the sounds travel. Okay. So here now, to understand the meaning of sound and how the vibration help to make this sound, try to listen carefully to this video.
Have you ever seen a movie or cartoon that shows characters hearing things in space? Well, you really can't hear in space. You don't hear sound in space because sound waves can't travel through empty space. All sound waves need a medium to travel through, so even though explosions and rockets firing in space look spectacular, they don't make any noise at all.
So from this video, sound needs to vibrate. To hear the sound, the particles needs to be vibrated. Okay, without vibrating the air, without vibrating the medium, for example air, liquid or solid, you will not hear the voice. So to understand more, look at the second video. It will describe the waves of sound
wave
and what are how to classify them, to classify these waves.
Sound waves are longitudinal waves. This means that they vibrate in the same direction as the direction they're traveling. Sound waves are also called compression waves. This means that particles squeeze together and then spread out. Click play to learn more about sound waves. Sound waves carry sound through a medium. The medium can be a solid, liquid, or gas. As sound waves travel, they cause particles in the medium to vibrate. The particles move closer together at times and then spread out. Sound waves need these particles because sound waves can't travel through empty space. This part of a sound wave is called a compression. What do you notice about the particles in a compression? They're close together or compressed. Remember, sound waves are longitudinal. They vibrate in the direction in which they travel. So a compression will move in the same direction as the sound wave is traveling. This part of a sound wave is called a rarefaction. How is a rarefaction different from a compression? In a rarefaction, the particles are more spread out. Like a compression, a rarefaction in a sound wave will move in the same direction as the wave travels. Sound waves can travel through many different mediums or materials, such as air, water, and even solids, such as walls. Particles in the medium squeeze together in compressions and spread apart in rarefactions. But a sound wave always needs particles in order to travel. Sound waves can't travel in a vacuum. If there are no particles, there can be no sound.
So from the video we saw that sound is a longitudinal wave. Okay. Also called compression waves. As you see, look at this one. The yellow part represent rarefaction, but the blue one represent compression because it has here, because the sound wave they are made of compression and rarefaction, are called compression waves. Okay, and as you know, as you heard in the video, sound cannot travel in vacuum. A vacuum, it means it doesn't contain any particles, no liquid, no gas, no solid. So no vibration for any particles, so the sound cannot travel in vacuum, but it can travel in three parts. It can travel in solid, liquid, and gas. For any question, you can send me your questions, or if you need to understand more, you can send me your question on portal. Thank you for listening.